Welcome to Sleepless Ancient Odyssey. The day is done. It is time now to let the noise of your world fade into silence. Find your most comfortable position, and for the next few moments, simply relax. Tonight's Odyssey is about to begin. Tonight, we journey to the land of the Nile, beneath skies that have watched over humanity for 5,000 years. You will witness the birth of celestial science. You will walk among priest-astronomers who mapped eternity itself, and you will discover how an ancient civilization read the heavens, not merely to mark time, but to touch the divine. This is not merely history. This is the story of humanity's first great conversation with the cosmos. Whether you are here for a story to captivate your mind, or a grand narrative to accompany you to sleep, your journey starts now. If you enjoy these odysseys, subscribe, and join us every time we travel to the past. Now, let us begin. The Nile flows north through the desert, a ribbon of life cutting through an ocean of sand. For as long as human memory extends, it has risen and fallen with the seasons, flooding the fields, retreating to reveal fertile black earth, then flooding again. The pattern repeats. Always it repeats. And the people who live along its banks have learned to read this rhythm as one reads the lines of a sacred text. But the river alone does not tell them when to plant, when to harvest, when to prepare for the waters that will sustain them. For that, they look up. The sky above Egypt is vast, unpolluted by the lights of cities that will not exist for millennia. It stretches from horizon to horizon, a dome of infinite darkness scattered with points of light. These lights do not simply decorate the night. They move, they dance, they rise and set in patterns that, to the careful observer, mirror the patterns of life along the river below. It is the 4th millennium before the Common Era. The Great Pyramids do not yet exist. Writing is still centuries away from its full flowering. But already, the people of the Nile Valley are watching the stars with an intensity that borders on reverence. They notice that certain stars appear in the eastern sky just before dawn at particular times of year. They observe that the brightest star of all, the one that will later be called Sirius, appears on the horizon precisely when the Nile begins its annual flood. This is not coincidence. This is pattern, and pattern is the beginning of understanding. The early Egyptians are not astronomers in the way we understand the term. They have no telescopes, no mathematical models of planetary motion, no concept of gravity or the vast distances between celestial bodies. But they have something else: patience, observation, and an unshakable belief that the heavens and the earth are connected by invisible threads of divine order. They watch the sun trace its path across the sky, rising in the east, setting in the west, disappearing into the underworld at night, before being reborn at dawn. They see in this daily journey a reflection of their own beliefs about death and resurrection. The sun god Ra travels through the darkness, battling the forces of chaos, emerging victorious each morning to bring light and life back to the world. The moon, too, holds their attention. It waxes and wanes, dies, and is reborn, following a cycle that seems to govern the rhythms of fertility, of women's bodies, of the very pulse of life itself. They divide its cycle into smaller segments, creating the first calendars, the first attempts to impose human order on celestial time. And then there are the stars that do not move with the others. 5 wanderers that drift through the fixed constellations, following paths that seem erratic until observed long enough. These are special. These are the gods themselves, walking among the stars. Mars, with its reddish hue, is Horus the Red. Venus, brilliant in the evening and morning sky, is the star of the horizon. Saturn, Jupiter, Mercury, each receives its own identity, its own place in the cosmic mythology. The earliest Egyptian sky watchers have no written records to guide them. Each generation must learn from the one before, memorizing the positions of stars, the timing of celestial events, the correlations between sky and earth. Knowledge is preserved in memory, in oral tradition, in the careful training of those who will become the keepers of celestial wisdom. These proto-astronomers are also priests. The two roles are inseparable. To study the heavens is to study the realm of the gods. To predict celestial events is to demonstrate divine favor, to prove oneself worthy of interpreting the will of the cosmos. The temples that will rise along the Nile in centuries to come will be built with their roofs open to the sky, their walls aligned to the movements of the sun and stars, their very architecture a bridge between earth and heaven. But we are still in the time before the great temples, before the pyramids, before the dynasties that will rule for 3,000 years. We are in the time of watching, of learning, of slowly accumulating the observations that will become the foundation of one of history's most sophisticated astronomical traditions. The desert night is cold. A priest sits atop a mud brick structure, his eyes fixed on the eastern horizon. He has been taught which star to watch for, which moment to wait for. His teacher learned from his teacher, who learned from his teacher, stretching back through generations to a time no one can remember. Soon, he knows, the star will appear, and when it does, he will descend from his post and inform the village. The flood is coming. Prepare the fields, mark the boundaries. The river will rise, the earth will be renewed, and life will continue as it has always continued. The star appears, a brilliant point of light breaking the darkness just before the sun follows. The priest stands, his vigil complete, his duty fulfilled. He does not know that this star is Sirius, that it is 8.6 light years away, that its appearance is not causing the flood, but merely coinciding with it. He does not need to know these things. He knows what matters. The sky speaks, and those who listen can read the future. This is where it begins. On a rooftop in the desert, with a man watching the stars, with a tradition being born that will outlast kingdoms and conquerors. The star has many names. Sopdet, Sothis, the Nile star, the flood herald. But to the Egyptians of the Old Kingdom, it is simply the most important light in the sky after the sun itself. Its heliacal rising, that first appearance in the dawn sky, after weeks of invisibility, marks the beginning of the year, the start of the inundation, the renewal of all things. Imagine the significance of this. An entire civilization's calendar built around a single star. The first day of the year is not an arbitrary choice, not a political decision or a mathematical convenience. It is the morning when Sopdet rises, when the Nile begins to swell, when the cycle of Egyptian life completes itself and begins anew. The correlation is remarkable. Year after year, century after century, the star appears just as the flood waters arrive. To the Egyptian mind, this cannot be accident. The goddess Sopdet, for the stars divine, must be controlling the flood. Or perhaps she is warning the gods below that the time has come. Or perhaps the flood itself rises in celebration of her return to the sky. The mechanism does not matter as much as the pattern, and the pattern is perfect. Well, almost perfect. Because here is where Egyptian astronomy begins to reveal its sophistication. The priests who watch the sky notice something subtle, something that takes generations to confirm. The stars rising and the flood's arrival do not always align precisely. Some years, the flood comes early. Some years, it comes late. And over very long periods, centuries long, the star seems to be drifting ever so slightly against the solar year. This is precession, though they do not call it that. This is the slow wobble of Earth's axis, causing the positions of stars relative to the sun to shift over vast timescales. But the Egyptians, lacking our model of planetary mechanics, must find another explanation. Perhaps the gods are adjusting the cosmic order. Perhaps the star herself is choosing different moments to appear. Or perhaps time itself is more complex than simple repetition. What they do understand is this: they need a more reliable calendar, one tied to the star, yes, but one that does not depend on the star alone. And so they create something extraordinary. They divide the year into 3 seasons of 4 months each, with each month containing 30 days. 3 times 4 times 30 equals 360. Add 5 extra days at the end, days that belong to no month, days of celebration and chaos, and you have 365. It is not perfect. The solar year is actually 365 and 1/4 days long, but it is remarkably close, and more importantly, it is consistent. The civil calendar, as it will later be called, does not depend on observation. It does not shift with the flood or the star. It simply proceeds day after day in perfect mathematical order. But they do not abandon the star. Instead, they maintain 2 calendars simultaneously. The civil calendar, for administration, for taxes, for the mundane organization of society, and the stellar calendar for religion, for ritual, for the sacred moments when earth and heaven must be precisely aligned. This dual system reveals something profound about the Egyptian mind. They are practical and mystical in equal measure. They understand the need for regularity in human affairs, but they never forget that true time, cosmic time, belongs to the gods. They are interpreters of divine will, guardians of cosmic order, intermediaries between the human and the eternal. They rise before dawn to watch for the stars. They track the sun's path across the sky with instruments we are only beginning to understand. They record the positions of the wandering stars, the planets, noting when they appear, when they disappear, when they move forward through the constellations, and when, mysteriously, they seem to move backward. These retrograde motions of the planets perplex them. How can a god walk backward across the sky? What does it mean when Mars reverses its course, or when Venus disappears from the evening sky, only to reappear weeks later in the morning? They develop theories, mythological explanations that make sense within their worldview. The gods are battling. The gods are traveling to the underworld. The gods are visiting one another in their celestial palaces. They do not know that retrograde motion is an illusion created by Earth's own movement around the sun. They do not know that the planets are worlds like their own, following elliptical orbits through empty space, but they know the patterns. They can predict when Mars will begin its backward journey. They can calculate when Venus will transition from evening star to morning star. Their predictions are not always perfect, but they are remarkably accurate for a civilization without advanced mathematics or optical instruments. In the temples, on the walls, they begin to record their knowledge, first in simple marks and symbols, later in the flowing script of hieroglyphs. They create star clocks, decorating tomb ceilings with maps of the night sky, ensuring that the dead can navigate the underworld by the same stars that guided them in life. They paint Nut, the sky goddess, arching over the earth, her body scattered with stars, her mouth swallowing the sun at dusk, her womb birthing it at dawn. These are not mere decorations. These are textbooks, reference guides, sacred texts that preserve astronomical knowledge in stone and paint. When archaeologists excavate these tombs millennia later, they will find detailed astronomical tables, predictions of stellar positions, calculations of planetary movements. The Egyptians are not just watching the sky, they are studying it with a rigor that rivals any scientific tradition. The flood star rises, another year begins. The priests mark their records, comparing this year's observations with those of decades and centuries past. They are building something unprecedented, a continuous astronomical record spanning thousands of years. No other civilization will match this achievement for millennia. The patient accumulation of data, the careful transmission of knowledge from one generation to the next, the unwavering belief that the sky holds secrets worth dedicating one's life to uncovering. The pyramids rise from the desert, geometric mountains crafted by human hands, monuments to the pharaohs who commissioned them and the gods who supposedly inspired them. But these massive structures are more than tombs, more than displays of royal power. They are astronomical instruments, precisely aligned to the heavens, embodying in stone the Egyptian understanding of cosmic order. The Great Pyramid of Khufu, largest of them all, reveals this celestial orientation in every dimension. Its sides face the cardinal directions with astonishing accuracy, deviating from true north by less than 1/15 of a degree. In an age before magnetic compasses, before satellites, before any of the tools we take for granted, Egyptian architects achieved a precision that modern engineers struggle to explain. How did they do it? The answer lies in the stars, specifically in the circumpolar stars, those that never set below the horizon, that circle eternally around the celestial pole. The Egyptians called them the imperishable ones, the indestructibles, stars that never died, that never descended into the underworld, like the sun and other stars. These were the most sacred stars, the eternal witnesses, the fixed points around which all else revolved. To align a pyramid, priest-astronomers would observe these circumpolar stars throughout the night, tracking their positions, calculating the exact point around which they rotated. This point, the celestial North Pole, provided the reference for true north. It was painstaking work, requiring multiple nights of observation, careful measurement, and mathematical calculation. But the result was a structure aligned not to the ephemeral landscape of Earth, but to the eternal geometry of the cosmos. The pyramids, however, are only the beginning. As Egyptian civilization matures, temples proliferate along the Nile, each one a carefully designed instrument for capturing and channeling celestial light. At Karnak, the great temple complex at Thebes, the main axis stretches east to west, oriented so that on the winter solstice, sunlight penetrates through the entrance down the long hypostyle hall, illuminating the inner sanctuary at the precise moment of the sun's southernmost position. This is not accident, this is intention. The temple becomes a calendar in stone, marking the solar year through the play of light and shadow. On other days, the sanctuary remains in relative darkness, lit only by artificial light. But on the solstice, the sun god himself enters his earthly house, his light touching the sacred spaces where normally only priests may tread. At Abu Simbel, far to the south, Rameses II constructs a temple carved directly into a mountainside. Its inner sanctuary contains 4 seated statues. Rameses himself, deified, alongside the gods Amun-Ra, Ra-Horakhti, and Ptah. Twice a year, on dates that likely correspond to significant moments in Ramesses' life or reign, sunlight penetrates the entire length of the temple, 60 meters into solid rock, illuminating 3 of the 4 statues. Ptah, god of darkness in the underworld, remains in shadow, as is fitting for his nature. The engineering required for this is extraordinary. The temple builders must calculate the sun's position months in advance, must orient the structure with exquisite precision, must account for the gradual shift in solar position caused by precession. When modern engineers relocated the temple in the 1960s to save it from the rising waters of Lake Nasser, they attempted to preserve its astronomical alignment. Despite all their technology, they were off by a single day. But temples are not only aligned to the sun. Many orient towards specific stars or constellations. The Temple of Hathor at Dendera, one of the best preserved temples in Egypt, focuses on Sirius, the same flood star that has guided Egyptian agriculture for millennia. On certain nights, starlight from Sirius enters the temple, just as sunlight does at Karnak, marking celestial time through the architecture itself. The ceilings of these temples become canvases for astronomical knowledge. At Dendera, the famous zodiac ceiling depicts the constellations as the Egyptians understood them, a blend of indigenous tradition and later Greek influence. The sky goddess Nut stretches across the ceiling, her body forming the arc of heaven. Within her, are the decans, 36 groups of stars that the Egyptians used to mark the hours of the night, the months of the year, the unfolding of cosmic time. These decans are uniquely Egyptian. The concept is simple but profound. Identify 36 groups of stars distributed around the sky such that each one rises just before dawn for a period of 10 days, then gives way to the next. As the year progresses, the decans march across the sky, each taking its turn as the herald of morning. By knowing which decan rises at which time of night, priests can tell time after sunset, dividing the darkness into hours as surely as the sun divides the day. The system is not perfect. Stars do not rise at precisely regular intervals. The decans shift and blur at the edges. But for practical purposes, for religious ritual and agricultural planning, they work beautifully. They represent a sophisticated understanding of stellar motion, of the relationship between sidereal time and solar time, of the complex dance between Earth and stars that creates the patterns we observe. Inside the temples, in the houses of life, the Pharaohs, scribes and priests study these patterns. They learn the old texts, the astronomical tables compiled by their predecessors. They add their own observations, correcting errors, refining predictions, extending the great record that stretches back to the earliest dynasties. They are not innovating in the way we imagine innovation, not proposing new theories or revolutionary models, but they are perfecting, preserving, transmitting a body of knowledge that represents one of humanity's first systematic attempts to understand the cosmos. The temple is quiet in the hours before dawn. A priest stands in the courtyard, his eyes turned upward, waiting for a particular star to clear the eastern wall. He has calculated when it should appear, based on tables and observations and the accumulated wisdom of centuries. He holds his breath. The star appears precisely on schedule. He releases his breath, makes a mark on his papyrus, adds another data point to the vast collection. The knowledge grows, star by star, night by night, generation by generation. Darkness falls over Egypt. The sun has completed its daily journey, descending into the western horizon, entering the Duat, the underworld, where it will battle the serpent Apophis and the forces of chaos before emerging, victorious and renewed, in the east. This is not merely mythology to the Egyptians. This is cosmology, their explanation for the fundamental question, why does the sun disappear at night and return in the morning? But the night is not empty. The stars fill the darkness, and with them comes the need to measure time when the sun is absent. The Egyptians divide the night into 12 hours, mirroring the 12 hours of daylight, creating a symmetry that pleases both their aesthetic and their practical needs. But unlike the constant hours we use today, Egyptian hours stretch and contract with the seasons. A winter night hour is longer than a summer night hour. The darkness lasts longer when the sun's path is shortened. To mark these shifting hours, they use the decans, those 36 groups of stars that process across the sky throughout the year. By knowing which decan is rising, which is at its highest point, which is setting, a trained observer can estimate the time with reasonable accuracy. It is not precision by modern standards, but it is sufficient for the purposes that matter. Beginning rituals at the proper hour, maintaining the vigil of the gods, ensuring that no moment of the night passes without human acknowledgement. The priests who keep these night watches are called the hour watchers, or in some texts, the watchers of the stars. They spend their nights on temple roofs, in observation chambers, in structures designed specifically for viewing the sky. They memorize the decanal tables, learning which stars mark which hours in which seasons. They become human clocks, living instruments of time measurement. But they are measuring more than time. They are participating in the cosmic order, ensuring through their vigilance that the universe continues to function as it should. There is a deep belief, never quite articulated but always present, that human observation somehow sustains the cosmos. If the priests stop watching, if the rituals cease, if the connection between earth and heaven is broken, Perhaps the sun will not return. Perhaps chaos will triumph. Perhaps the fragile order that separates creation from void will collapse. This belief manifests in the elaborate rituals that mark each stage of the sun's journey. At sunset, offerings are made, prayers recited, to strengthen Ra for his battle in the underworld. Throughout the night, at each decanal hour, additional rituals occur, symbolic support for the god in his struggle. And at dawn, when the sun re-emerges, triumphant and glorious, there is celebration, thanksgiving, acknowledgement that the cosmic order has held for another day. The tomb walls of the New Kingdom pharaohs preserve these beliefs in stunning detail. The books of the underworld, as modern scholars call them, map the 12 hours of night as 12 regions of the Duat, each with its own dangers, its own inhabitants, its own portion of the sun god's journey. These are not arbitrary divisions. Each hour corresponds to a stage of stellar position, to a decanal marker, to an observable celestial event. The astronomical knowledge embedded in these religious texts is profound. The priests who composed them understood that the sun, its path through the underworld, could be tracked through the movements of stars. When certain stars were visible, the sun was in certain regions of the Duat. The spiritual and the astronomical were inseparable, two ways of describing the same reality. In the royal tombs, star clocks cover the ceilings, complex tables showing which stars mark which hours throughout the year. These tables require decades of observation to compile, generations of refinement to perfect. They represent one of the earliest attempts at systematic astronomical data collection, predating similar efforts in Mesopotamia and far surpassing anything attempted in Europe for millennia. Some of these star clocks are damaged, the paint faded, the hieroglyphs eroded by time and tomb robbers. But enough survive to reveal the sophistication of the system. The Egyptians understood that the stars appearing at a given hour changed throughout the year as the earth moved in its orbit. They created separate tables for each season, sometimes for each month, tracking the shifting patterns with meticulous care. And they noticed something else, something that would perplex astronomers until the modern era. The stars themselves were not perfectly fixed. Over very long periods, the positions of stars relative to the seasons shifted. The spring stars of one century were not quite the spring stars of a century later. This is precession again, the 26,000-year wobble of Earth's axis, causing the celestial pole to trace a slow circle through the stars. The Egyptians did not understand the mechanism, could not explain why the stars shifted, but they observed it, recorded it, adjusted their tables accordingly. Their astronomical texts show awareness that the old calculations become inaccurate, that new observations are needed, that the cosmos is not quite as perfectly eternal as their theology suggests. This tension between the ideal of unchanging cosmic order and the observed reality of slow change never quite resolves in Egyptian thought. Both things are true simultaneously. The universe is eternal and perfect, and the universe is constantly adjusting. The gods maintain order, and the gods are constantly working to maintain order against forces that would disrupt it. The sky is a realm of mathematical precision, and the sky requires constant human effort to keep it so. A priest marks the passage of another night hour. The appropriate deacon has reached its assigned position. He makes his notation, performs his ritual, and settles in to wait for the next marker. The night is long, but he is patient. He has been trained for this, his entire life preparation for these hours of darkness, these moments of connection between the human and the divine. Above him, the stars turn in their ancient patterns, indifferent and eternal, yet somehow dependent on his watching, his recording, his maintaining of the cosmic order through sheer attentive presence. 5 points of light move through the constellations, distinguishing themselves from the fixed stars by their restless motion. The Egyptians noticed them early, these wandering stars, these gods who walk among the eternal ones. They are brighter than most stars, their light steady rather than twinkling, their paths complex and puzzling. The wanderers have names, identities, associations with particular deities. Horus, who limits the two lands, is Jupiter, majestic and slow in its journey through the sky. Horus the Red is Mars, its ruddy color suggesting blood and war. Sebegu is Mercury, swift and elusive, rarely visible, always near the sun. Golden Horus, or the One, who crosses, is Venus, impossibly bright, appearing as evening star, disappearing, then returning as morning star. And finally, Horus, bull of the sky, is Saturn, distant and dim, taking decades to complete its circuit. Tracking these planets becomes the obsession for the priest-astronomers. Unlike the fixed stars whose positions can be memorized and passed down through generations, the wanderers require constant observation. Their positions change night by night. Their brightness varies. They speed up, slow down, stop, reverse direction, stop again, then resume their forward motion. To predict their movements requires not just observation, but calculation, pattern recognition, an intuitive grasp of cycles within cycles. The Egyptians developed sophisticated tables for planetary motion, particularly for Venus, the brightest and most regular of the wanderers. They noticed that Venus follows a fairly consistent pattern. It appears as evening star for several months, gradually moving away from the sun, reaching maximum distance, then returning toward the sun and disappearing. But Venus is the easy one. Mars, with its longer cycle and dramatic retrograde motions, poses greater challenges. The Egyptians observe that Mars grows brighter and dimmer in a pattern that repeats roughly every 2 years. They note that its retrograde motion, that strange backward journey through the stars, always occurs when Mars is at its brightest, when the planet's reddish color is most pronounced. They do not know that this brightness and retrograde motion occur because Earth is overtaking Mars in its orbit, that the apparent backward movement is an illusion of perspective. They develop mythological explanations instead. Perhaps Horus the Red is battling with Set, the god of chaos and the desert, their struggle causing the erratic motion. Perhaps the planet is descending into the underworld, following a different path than the sun, emerging again to resume its forward journey. Jupiter and Saturn, more distant, move more slowly. Jupiter takes roughly 12 years to circuit the sky, moving through the zodiacal constellations at a stately pace. Saturn takes nearly 30 years, so slow that a single human lifetime barely encompasses its full journey. These long cycles make prediction difficult. An astronomer might observe Saturn in one constellation at the beginning of his career and see it return to that same constellation only near the end of his life. Yet they persist in tracking these distant wanderers. Perhaps it is the belief that all celestial events have meaning, that the positions of the planets influence earthly affairs, that understanding the sky provides insight into the will of the gods. Perhaps it is simple curiosity, the human need to understand patterns, to impose order on complexity. Mercury, closest to the sun, proves most difficult to observe. It appears only briefly at twilight, either just after sunset or just before dawn, never straying far from the sun's glare. Weeks can pass without a single sighting. The Egyptians developed techniques for catching glimpses of Mercury during these narrow windows, learning to look at just the right time, in just the right place. knowing that the planet's appearance is fleeting but predictable. The planetary observations accumulate over centuries. Scribes in the houses of life copy and recopify the tables, each generation adding its observations to those of the past. Errors creep in, are corrected, creep in again. But the fundamental knowledge persists. The wanderers move in patterns, and those patterns, though complex, can be understood, predicted, marked in the eternal record. There is something poignant about this effort. The Egyptian priest-astronomers are attempting to predict the positions of planets using nothing but naked eye observation and arithmetical calculation. They lack algebra, lack calculus, lack any understanding of gravity or orbital mechanics. Yet they succeed, to a remarkable degree, in anticipating where planets will be, when they will begin their retrograde motions, when they will return to particular constellations. Their success comes from patience, from the willingness to observe and record over generations without expecting immediate understanding, from trust that patterns will emerge if enough data accumulates. It is a different approach to knowledge than the theoretical models developed by later Greek astronomers. The Egyptians are not asking why the planets move as they do, not seeking mechanical explanations. They are asking what the planets will do next, how to predict their behavior, how to read their positions as signs from the divine realm. A scribe sits in the cool darkness of the temple library, copying a planetary table by lamplight. His hand cramps from hours of writing, his eyes strain to see the faded hieroglyphs on the ancient papyrus he is reproducing. But he continues, carefully transferring the observations of his predecessors onto fresh papyrus, preserving knowledge that has been accumulating for over 1,000 years. He adds a note in the margin, his own observation of Mars from the previous month, a small addition to the vast corpus, one more data point in humanity's attempt to understand the wandering stars. At the heart of Egyptian astronomy lies a concept that is not quite science and not quite religion, but something that encompasses both. Ma'at. The word defies simple translation. It means truth, justice, order, balance, harmony, the proper way things should be. Ma'at is the principle that keeps the sun rising, the stars turning, the Nile flooding. It is cosmic law, divine order, the structure that prevents the universe from dissolving into chaos. The goddess Ma'at, depicted with an ostrich feather on her head, represents this principle in personified form. But Ma'at is more than a goddess. It is the foundation of existence itself, the reason there is something rather than nothing, the force that maintains the delicate balance between creation and void. Egyptian astronomy, at its deepest level, is the study of Ma'at as manifested in the heavens. The regular motions of the sun, moon, and stars are proof that Ma'at holds. The predictable patterns, the mathematical relationships, the cycling and recycling of celestial events all demonstrate that the universe operates according to principle, that divine order is not mere hope, but observable fact. This understanding shapes how Egyptians do astronomy. They are not seeking to discover natural laws in our sense, not trying to explain celestial mechanics through impersonal physical forces. They are documenting Ma'at, recording the evidence of cosmic order, creating a catalog of how the universe properly functions when the gods maintain balance. When observations do not match predictions, when a planet appears in an unexpected position, or an eclipse occurs at an unanticipated time, this is not scientific failure, but potential cosmic crisis. Has Ma'at been violated? Are the forces of chaos gaining strength? What ritual or offering might be needed to restore proper order? This makes Egyptian astronomy deeply conservative. Innovation is not valued as it will be in later scientific traditions. The goal is not to develop new theories, but to preserve old knowledge, to maintain the connection with tradition that stretches back to the time of the gods themselves. When new observations are made, They are incorporated into the existing framework, not used to overturn it. Yet this conservatism does not prevent sophistication. The astronomical tables of the late period, when Egypt is ruled by foreign dynasties and Greek influence is strong, show remarkable precision. The priests can predict lunar eclipses, can calculate the positions of planets years in advance, can correct for the slow drift of the calendar relative to the seasons. They develop instruments to aid their observations. The Merket, a sighting tool made of palm rib with a plumb line, allows precise determination of north and the tracking of stellar positions. Used in pairs, Merkets can establish a north-south line, enabling accurate alignment of temples and monuments. The shadow clock, a simple device with a crossbar that casts shadows of different lengths depending on the sun's altitude, divides the day into segments, creating a portable sundial. For nighttime observations, they developed the bay, a tool shaped like a palm branch with a weighted plumb line, allowing sighting along the vertical plane. With this, they can measure the altitude of stars, noting when particular stars reach particular heights above the horizon. Combined with knowledge of which stars appear at which times of year, this allows increasingly precise timekeeping and astronomical calculation. But the instruments are tools in service of a deeper purpose. They help maintain Ma'at by allowing humans to track the cosmic order more accurately, to align their temples more precisely, to time their rituals more correctly. The technology is sophisticated, but it is sacred technology, imbued with religious significance beyond its practical function. The architecture of Egyptian temples reflects this principle. They are not merely buildings, but cosmic diagrams, three-dimensional maps of the relationship between earth and heaven. The pylon gates represent the horizon. The hypostyle halls, with their massive columns, are forests of stone, recalling the primordial marsh from which creation emerged. The inner sanctuary is the Holy of Holies, the place where heaven and earth meet, where the divine statue resides, where cosmic order is maintained through daily ritual. These temples are aligned with astronomical precision, not for practical reasons, but for theological ones. When sunlight enters the sanctuary on the solstice, it is not merely demonstrating astronomical knowledge, but enacting a sacred drama, the reunion of the sun god with his earthly dwelling. When starlight from Sirius illuminates a temple corridor, it is the goddess herself visiting her temple, her presence confirmed by the very light streaming from her celestial form. The festival calendar of Egypt is built on astronomical events. The rising of Sirius marks the new year and the beginning of the flood season, a time of celebration and renewal. The solar solstices bring festivals of the sun's rebirth, marking the moment when the days begin to lengthen again after the winter's darkness. Lunar festivals mark the new moon, full moon, and quarters, celebrating the eye of Horus as it waxes and wanes. Every ritual, every offering, every hymn and prayer reinforces the connection between human action and cosmic order. The priests are not passive observers of the sky, but active participants in maintaining Ma'at. Their observations, their calculations, their rituals all work together to sustain the universe in its proper functioning. And yet, despite this religious framework, real astronomical knowledge accumulates. The priests learn the rates at which the wandering stars move through the sky. They discover the relationships between lunar cycles and solar years. They calculate the length of the solar year to remarkable precision, 365 and 1/4 days, exact enough that the error accumulates to only 1 day every 120 years. This precision emerges not from theoretical physics, but from patient observation over centuries, from comparing records across generations, from refining estimates through trial and error. It is empirical science in the service of theological goals, yet it is science nonetheless. An elderly priest stands in the temple courtyard at dawn, his final dawn after a lifetime of service. He has watched the skies for 50 years, added countless observations to the temple archives, trained the younger priests who will continue the work after his death. He knows the patterns of the stars as intimately as he knows the lines of his own weathered hands. As the sun rises, golden and eternal, he whispers a prayer of thanks to Ma'at, to the cosmic order that has held throughout his lifetime and will hold, he trusts, for lifetimes beyond counting. The universe is vast, but it is orderly. The gods are distant, but they are faithful. The stars turn in their courses, and that turning is proof enough of meaning. The sun darkens in the middle of the day. Shadow falls across the land, unnatural and wrong. Birds cease their singing. A chill wind rises despite the summer heat. The people look up, and what they see defies all order. The sun is being devoured. Solar eclipses terrify ancient peoples everywhere, but for the Egyptians, with their deep connection between solar, theology, and cosmic order, an eclipse is particularly ominous. This is Apophis, the great serpent of chaos, succeeding in his eternal attempt to swallow Ra. This is the triumph of disorder over order, darkness over light, chaos over Ma'at. Yet the priests know something the common people do not. They have seen this before. They have recorded previous eclipses, noted the circumstances, calculated patterns. They understand that eclipses, while terrifying, are temporary, that the sun always returns, that this too is part of the cosmic order, frightening but ultimately survivable. Predicting eclipses, however, proves extraordinarily difficult. The Egyptians observe that lunar eclipses, when the moon darkens and sometimes turns blood red, occur only at full moon. They note that solar eclipses happen only at new moon. But not every new moon brings a solar eclipse, nor every full moon a lunar one. There must be additional factors, hidden patterns not yet fully understood. Over centuries, they accumulate eclipse records. They notice that eclipses tend to occur in series, separated by specific intervals. A solar eclipse visible from Egypt might be followed by another 18 years later, then another 18 years after that. These cycles, which later astronomers will call the Saros cycle, suggest that eclipse prediction might be possible with enough data. But the Egyptians never quite achieve reliable eclipse prediction. The geometry is too complex, the calculations too demanding for their mathematical tools. They can say that an eclipse is likely in a particular year, can narrow it down to a season, sometimes to a month. But exact prediction, knowing precisely when the sun will darken and where on earth the eclipse will be visible, remains beyond their reach. This failure does not diminish their astronomical achievement. Eclipse prediction will challenge civilizations for millennia. The Babylonians, with their more advanced mathematics, will have better success, but even they cannot predict solar eclipses with full accuracy until much later in history. What the Egyptians do develop is a rich body of eclipse lore, rituals for protecting the sun and moon during these cosmic crises. When a lunar eclipse occurs, priests perform ceremonies to help the moon fight off the darkness that assails it. They recite hymns, make offerings, sometimes play drums and instruments to frighten away the forces of chaos. The noise, the ritual, the human intervention all serve to support the moon in its battle. Solar eclipses demand even more urgent response. Special rituals are performed to strengthen Ra, to aid him in his struggle against the serpent. The pharaoh himself might participate, as the living embodiment of Horus, joining his power to that of the sun god. The entire nation effectively goes on alert, every temple performing its part in the cosmic drama unfolding overhead, and always the eclipse passes. The sun re-emerges, brilliant and victorious. The moon regains its light. Order is restored. The rituals have worked. The gods have prevailed. Mayat continues. Whether the rituals actually affect the eclipse is, to the Egyptian mind, not a meaningful question. The rituals and the eclipse's end are part of the same reality. the human and cosmic operating in parallel, both necessary for the proper functioning of the universe. But eclipses are not the only celestial omens the Egyptians watch for. Comets, those hairy stars that appear unpredictably and drift across the sky over days or weeks, inspire both wonder and dread. They are not part of the regular order, not accounted for in the star tables, not associated with any known deity. Their appearances seem random, their meanings unclear. Egyptian texts rarely mention comets, which is itself revealing. The Egyptians are so focused on regular, predictable celestial phenomena that irregularities like comets do not fit easily into their worldview. Some texts suggest that comets are evil, manifestations of chaos breaking through into the ordered realm. Others propose they are messengers, divine communications requiring interpretation. Meteors, shooting stars that flash across the night sky and disappear, receive more attention. The Egyptians understand these as falling stars, literally, stars that have died and are descending into the underworld. They are not omens so much as natural events, sad perhaps, the death of a celestial being, but not particularly alarming. Many stars populate the sky, and the loss of a few does not threaten the cosmic order. The Milky Way, that river of faint light stretching across the heavens, holds special significance. Some texts identify it as a celestial Nile, a reflection of the earthly river in the realm of the gods. Others call it the pathway of Ra, the route the sun god travels during his nightly journey through the underworld. Still others see it as the body of Nut herself, the sky goddess in her most expansive manifestation. Different interpretations coexist without conflict. The Egyptian mind is comfortable with multiple simultaneous truths, with symbols having many meanings, with the cosmic order being too vast and complex for any single explanation to encompass. The Milky Way is a river and a pathway and a goddess all at once, each understanding revealing a different facet of divine truth. The zodiacal light, that faint cone of light visible in the west after sunset or the east before dawn, puzzles them. It is too faint to be a star or planet, too diffuse to be a comet, too regular to be an omen. Some texts describe it as the glow of the underworld, visible at the horizon where the barrier between realms is thinnest. Others suggest it is the breath of the gods, made visible in the twilight. These phenomena, both predictable and unpredictable, regular and irregular, fill the Egyptian sky with meaning. Every light, every shadow, every movement carries significance. The cosmos is not empty space scattered with random objects, but a realm densely packed with divine presence, with symbolism, with connections to the earthly realm and the underworld alike. A priest records an eclipse in the temple archive, adding it to the list of previous eclipses, noting the date according to both the civil and lunar calendars, describing the extent of the shadow, the duration of totality. He does not understand the geometry of shadow cones, does not know that the moon is blocking sunlight from reaching Earth. But he understands the pattern, the reality that eclipses come and go, that they are part of the cosmic order, terrifying but survivable proof that even chaos has its limits, that Ma'at ultimately prevails over Apophis, that the sun always returns. The library at the Temple of Thoth in Hermopolis contains hundreds of papyrus scrolls, carefully stored in clay jars, protected from the dry air and occasional dampness that threatens all written material. These scrolls represent centuries of accumulated astronomical knowledge, star tables, decanal lists, planetary observations, eclipse records, calendrical calculations. Yet errors inevitably creep in. A scribe misreads a faded hieroglyph, copies a number incorrectly, skips a line by accident. These errors accumulate over generations of copying until the transmitted text differs significantly from the original. Later scribes, noticing discrepancies between different copies of the same text, must make judgments about which version is correct, sometimes introducing new errors while attempting to correct old ones. Despite these challenges, the core astronomical knowledge persists. The fundamental observations, the basic patterns, the essential calculations survive centuries of transmission because multiple copies exist, because the knowledge is also preserved in temple architecture and ritual practice, because any single error can be checked against other sources. The Egyptians developed sophisticated systems for preserving and transmitting knowledge. Young priests spend years in training, memorizing astronomical tables before they are even allowed to make observations. They learn the names of stars and constellations, the movements of planets, the calculations for the calendar. This oral tradition supplements the written record, providing a check against textual corruption and ensuring that knowledge survives even if documents are damaged or destroyed. Teachers pass down not just facts, but methods: how to sight along a merket, how to identify the decanal stars, how to calculate the age of the moon from its appearance, how to determine when a planet will begin its retrograde motion. These practical skills, demonstrated teacher to student over generations, are as important as the written tables and records. Some knowledge is deliberately kept secret, restricted to the priesthood, particularly information connected with the most sacred rituals and the most powerful astronomical alignments. The common people know that certain stars mark certain seasons, that the sun follows a yearly path, that the moon waxes and wanes, but the detailed calculations, the precise predictions, the subtle corrections for calendar drift, these remain the exclusive domain of the temple astronomers. This exclusivity serves multiple purposes. It maintains the priest's status as essential intermediaries between the human and divine realms. It ensures that astronomical knowledge is transmitted carefully from qualified teachers to prepared students, rather than being scattered widely where it might be corrupted or misunderstood. And it preserves the sacred character of the knowledge itself, keeping the secrets of heaven from those who might misuse them or fail to treat them with appropriate reverence. But Egyptian civilization is not static. Over 3,000 years, it experiences conquest, foreign rule, cultural exchange, and fundamental transformation. Each wave of change threatens the astronomical tradition, yet also, surprisingly, helps preserve it. When Alexander the Great conquers Egypt in 332 BCE, bringing Greek culture and Greek ideas, the Egyptian astronomical tradition faces its greatest challenge. The Greeks have their own astronomy, their own understanding of the cosmos, their own methods and instruments. Some Greek scholars dismiss Egyptian astronomy as primitive, based on observation rather than mathematical theory, concerned with practical prediction rather than understanding the true nature of celestial mechanics. Yet others recognize the value of the Egyptian tradition. The millennia of observations, the detailed records of planetary positions, the accurate calendrical systems, all of this is treasure to astronomers seeking to refine their own theories. Greek scholars come to Egypt, study in the temples, learn from the priests. They copy Egyptian star tables, adapt Egyptian instruments, incorporate Egyptian observations into their own work. This exchange flows both ways. Egyptian astronomers learn Greek geometric methods, Greek planetary theory, Greek mathematical techniques. They begin combining their observational tradition with Greek theoretical frameworks, creating a hybrid astronomy more powerful than either tradition alone. The zodiac provides an example. The Egyptians have their own constellations, their own ways of dividing the sky. But Greek astrology, with its 12 zodiacal signs, and its emphasis on planetary positions within those signs, gradually influences Egyptian practice. By the Ptolemaic period, Egyptian astronomical texts show a blend of indigenous and Greek elements, Egyptian decans coexisting with Greek zodiacal signs, traditional temple astronomy incorporating new mathematical techniques. The Temple of Hathor at Dendera, built during this Ptolemaic period, displays this synthesis beautifully. Its ceiling contains both traditional Egyptian astronomical imagery and Greek zodiacal representations, merged into a single coherent system. The decans are there, the sky goddess Nut is there, but so are Greek planetary symbols and zodiacal figures. It is Egyptian and Greek simultaneously, a testament to cultural exchange and the universality of the human desire to understand the heavens. When Rome conquers Egypt in 30 BCE, the astronomical tradition continues, now under yet another foreign power. Roman administrators appreciate Egyptian calendar expertise, Egyptian timekeeping, Egyptian agricultural astronomy. The knowledge proves useful regardless of who rules, and so it survives, adapted and modified, but fundamentally intact. The final blow comes not from conquest, but from religious transformation. As Christianity spreads through Egypt in the early centuries of the Common Era, the pagan temples close, the priesthood disperses, the institutional framework that has supported astronomy for millennia collapses. The houses of life shut their doors, the observatories fall silent. The old gods, including the astronomical deities, are forbidden. Some knowledge transfers to the new Christian scholars, to the monasteries that become the new centers of learning. Some survives in folk practice, in agricultural customs that preserve ancient calendrical traditions even after their astronomical basis is forgotten. But much is lost, dispersed, allowed to fade as the texts decay and no one remains who knows how to read them. An old priest, one of the last trained in the traditional ways, carefully hides a collection of astronomical papyri in a sealed chamber, hoping that someday someone will value this knowledge again. He does not live to see whether his hope is fulfilled. The chamber remains hidden for centuries, the papyri slowly deteriorating in the darkness, the knowledge they contain sleeping, waiting for archaeologists who will not arrive for more than 1,000 years. The temples stand empty now, their ceremonies silenced, their priests gone, but the stones remain, and carved into those stones, painted on walls that will endure for millennia, is astronomical knowledge waiting to be rediscovered. The Egyptian astronomical tradition may have ended as a living practice, but it has left messages for the future, encoded in architecture and art, in texts buried in the dry sand, in patterns that patient excavation will slowly reveal. When European archaeologists begin seriously investigating Egypt in the 19th century, they find astronomical wonders everywhere they look. Temple alignments that point to solstice sunrises, star charts on tomb ceilings, texts describing planetary movements, calendars and calculations and observations stretching back thousands of years. It is a revelation, proof that sophisticated astronomical practice existed long before the Greeks, who had always been credited as the founders of astronomy. The decoding takes time. The hieroglyphic script must first be translated, a breakthrough achieved in the 1820s when Champollion finally cracks the code. Then scholars must learn to read the astronomical texts specifically, to understand the specialized vocabulary, the mathematical notations, the conventions used to record observations. Each discovery opens new questions, reveals new complexity. The zodiac ceiling at Dendera, for instance, becomes a sensation when it is discovered. Here is a complete star map from ancient Egypt, showing constellations, planets, the pathway of the sun. French archaeologists, during Napoleon's expedition to Egypt, actually removed the entire ceiling and transport it to Paris, where it becomes one of the treasures of the Louvre. The removal is vandalism by modern standards, but it ensures the ceiling's preservation and allows scholars worldwide to study it. From this zodiac and others like it, scholars reconstruct the Egyptian understanding of the cosmos. They identify the decans, previously known only from obscure textual references, as actual groups of stars with specific identities. They trace the evolution of constellation figures, seeing how Egyptian astronomy influenced Greek, which influenced Roman, which influenced medieval European, creating a chain of transmission that connects ancient Thebes to modern observatories. The Egyptian calendar becomes recognized as one of humanity's great intellectual achievements. Its 365-day year, divided into 12 months of 30 days plus 5 extra days, is strikingly similar to our modern calendar. In fact, the Egyptian calendar directly influenced the Julian calendar, which evolved into the Gregorian calendar we use today. Every time we mark a date, we are using a system with roots in the Nile Valley over 5,000 years ago. The discovery of star clocks in royal tombs reveals the sophistication of Egyptian timekeeping. These are not simple decorations, but functional astronomical tables, showing which stars mark which hours throughout the night in different seasons. Scholars painstakingly match the depicted stars with actual celestial bodies, calculating back through precession to determine when these clocks were accurate, using them to date the tombs themselves with remarkable precision. The planetary tables found in temple archives demonstrate that Egyptian astronomers could predict planetary positions years in advance. While their predictions were not perfect, they were impressively accurate given the limitations of naked eye observation and basic arithmetic. Comparisons with Babylonian astronomical texts reveal that the Egyptians were achieving similar results through different methods, another independent development of astronomical science. But perhaps the most profound legacy is architectural. The realization that Egyptian temples are precisely aligned astronomical instruments transforms how scholars understand these structures. They are not merely religious buildings, but observatories, calendars, three-dimensional maps of cosmic order. Their alignments encode astronomical knowledge in stone, preserving it in a form that survives long after texts decay and oral traditions fade. Modern archaeoastronomers, using computer programs to calculate the positions of sun and stars in the distant past, can now determine exactly what celestial bodies a temple's axis was aligned to, what celestial event a particular chamber was designed to capture. They discover that even structures built thousands of years apart maintain consistent astronomical alignments, proof of a continuous tradition passing knowledge across generations with extraordinary fidelity. This architectural astronomy influences how modern buildings are designed. Architects and designers, inspired by Egyptian examples, create structures that interact with sunlight, that mark solstices and equinoxes, that connect their inhabitants with celestial cycles. The Parliament House in New Zealand, the Jantar Mantar Observatory in India, even some modern museums and monuments incorporate alignments that echo ancient Egyptian principles. The scientific legacy extends further. Egyptian astronomy, through its transmission to Greece and then to the Islamic world, helped lay foundations for modern astronomy. The concept of a regular calendar based on astronomical observation, the practice of systematic record-keeping, the belief that celestial events follow predictable patterns, all of these, developed or refined by the Egyptians, became essential components of astronomy as a science. Even the word hour connects back to Egypt. The division of day and night into 12 segments each, creating our 24-hour day, originates with the Egyptians and their decanal stars. The hour as a unit of time is an Egyptian gift to civilization, so deeply embedded in how we structure our lives that we rarely pause to consider its origin. The zodiac, though Greek in its final form, contains Egyptian influences. Some zodiacal constellations derive from Egyptian antecedents. The concept of dividing the ecliptic, the sun's apparent path through the stars, into regular segments for tracking planetary motion owes something to Egyptian practice. Astrology, for better or worse, carries forward traditions that trace back, in part, to Nile Valley observations of how celestial events correlate with earthly ones. A modern astronomer, standing in the temple of Karnak, watches the winter solstice sun penetrate the sanctuary just as it did 3,000 years ago. The technology has changed. The theoretical understanding has advanced beyond anything the ancient Egyptians could imagine. But the fundamental human impulse remains the same: to watch the sky, to track its patterns, to find meaning in the movements of celestial bodies, to connect the earthly and the cosmic through patient observation and careful thought. The stones remember what the texts have forgotten. The temples preserve what the papyri have lost. And slowly, painstakingly, the story of Egyptian astronomy emerges from the ruins, revealing itself to those patient enough to look, dedicated enough to decode, humble enough to recognize the sophistication of a culture separated from us by millennia, but connected through our shared wonder at the stars. For all that has been discovered, much remains mysterious. The archaeological record is incomplete, the texts fragmentary, the full scope of Egyptian astronomical knowledge still only partially understood. Each answer raises new questions, each discovery hints at deeper layers waiting to be uncovered. Take the origins of the decans. Scholars know that 36 groups of stars were used to mark the hours and the passing of the year. They can identify many of these decanal stars in the modern sky, can trace how they were used in Egyptian timekeeping. But the original logic behind the selection of these particular stars, why these 36 and not others, remains unclear. Were they chosen purely for their rising times, or were there mythological or religious reasons for specific selections? The star clocks found in tombs show variations that are not fully explained. Different tombs from the same period sometimes use different decanal stars for the same hours. Are these regional differences? Are they corrections based on new observations? Are they the result of scribal error or deliberate religious choice? The variations are systematic enough to suggest intention, but the intention itself is obscure. Egyptian planetary theory, or lack thereof, puzzles scholars. The Babylonians developed sophisticated mathematical models to predict planetary positions. The Greeks created geometric models with epicycles and deferents. But the Egyptians, despite centuries of planetary observation, never seem to have developed comparable theoretical frameworks. Why? Were they simply not interested in the why behind planetary motion, content with predicting the what? Did they have theories that were not written down, preserved only in oral tradition now lost? Or did their religious framework, with its emphasis on divine action rather than natural law, prevent the development of physical models? The famous Dendera zodiac contains elements that remain controversial. Some figures clearly represent Egyptian deities and constellations. Others seem to be Greek importations, but a few are ambiguous, possibly representing stars or constellations now difficult to identify. And the dating of the zodiac itself, while generally agreed to be Ptolemaic period, has been debated, with some researchers proposing it encodes much older astronomical information. Then there is the question of Egyptian awareness of precession. Some texts seem to show knowledge that the positions of stars relative to the seasons slowly shift over time. But is this true understanding of precession, the wobble of Earth's axis over a 26,000-year cycle? Or is it simply observation of apparent irregularities without understanding the underlying cause? The Egyptians do not explicitly discuss precession, yet their star tables seem to account for it. The contradiction remains unresolved. The extent of Egyptian knowledge of eclipses is another puzzle. They certainly observed eclipses, recorded them, Understood, they occurred in patterns, but could they predict them? The evidence is ambiguous. Some texts suggest predictions were attempted, but no clear prediction method has been found in surviving documents. Perhaps the knowledge was restricted to the highest levels of the priesthood. Perhaps it was considered too dangerous to write down. Perhaps they never achieved reliable prediction, content with recognizing patterns after the fact. The purpose of certain architectural alignments remains debated. While major temples clearly align to solstices, equinoxes, or important stars, many smaller structures have alignments that do not obviously correlate with prominent celestial events. Are these aligned to more obscure astronomical phenomena? Are they oriented for religious reasons unrelated to astronomy? Or are some of these apparent alignments merely coincidental, the result of scholars finding patterns where none exist? The relationship between Egyptian astronomy and Mesopotamian astronomy is still being worked out. Both civilizations developed sophisticated astronomical practices independently, then came into contact during the late period. How much did they influence each other? Did ideas flow one direction more than the other? Were there earlier contacts that left no clear record? The similarities in some practices suggest interaction, but the differences are profound enough to confirm substantial independent development. And what of the common people? All the surviving astronomical texts and temple alignments reflect elite knowledge, the practice of the priesthood. What did ordinary Egyptians know about the sky? They certainly recognized the major constellations, knew the agricultural significance of Sirius, understood the lunar cycle. But beyond these basics, how much astronomical knowledge permeated everyday life? The absence of evidence is not evidence of absence, but the common voice, the folk astronomy of ancient Egypt, remains largely silent. Mediated by time and stone and the patient work of those who refuse to let the past remain silent. On a clear night in modern Egypt, far from the cities, the Milky Way still arcs across the sky as it did when the first Egyptian astronomer looked up and wondered. The same stars shine, following the same patterns, indifferent to the rise and fall of civilizations beneath them. Sirius still rises before dawn in the summer, though the Nile, dammed now, no longer floods in response. The planets still wander through their ancient paths. The moon still waxes and wanes. The sky has not changed, but our relationship to it has transformed utterly. We know now what the Egyptians could not, that the stars are distant suns, that the planets are worlds, that the universe is vast, beyond their wildest imagining. We can predict the eclipses with perfect accuracy, can send spacecraft to the planets the Egyptians watched from their temple roofs, can map the cosmos to its very edge. Yet for all our knowledge, something has been lost. The Egyptians lived under a sky that spoke to them directly, a sky filled with gods and meaning, a sky that connected them to cosmic order. Their astronomy was not separate from their religion, their science not divorced from their spirituality. The same observations that allowed them to plant crops at the right time also assured them that Ma'at held, that the universe had structure and purpose. Modern astronomy is more accurate, but less personal. We understand the mechanics of celestial motion better than any ancient civilization. But we do not see the sky as a realm of divine action, do not feel ourselves participants in cosmic drama. The sky has become an object of study rather than a source of meaning. Perhaps this is necessary progress. The Egyptian worldview, beautiful as it was also limited. They could not explain planetary motion except through mythology. Their understanding of eclipses was incomplete. Their calendar, though sophisticated, accumulated errors over time. The scientific revolution that separated the study of nature from religious interpretation enabled advances the Egyptians could never achieve. But something in the Egyptian approach deserves preservation: the sense of wonder, the patient observation over generations, the belief that understanding the sky matters deeply, not just for practical purposes, but for human meaning. The Egyptian astronomer was not just a technician calculating positions, but a seeker attempting to comprehend the cosmos and humanity's place within it. Modern astronomers sometimes rediscover this attitude. The astronomical knowledge encoded in temple architecture has been decoded, published, explained. The sky stretches above, vast and star-scattered, the same sky that watched over the first Egyptian kingdoms, that witnessed their zenith and their decline. Egyptian astronomy is gone as a living tradition, but its legacy permeates how we understand the cosmos and our place within it. Every calendar date, every hour marked, every astronomical observation recorded, carries forward something of what began in the Nile Valley 5,000 years ago. The story of Egyptian astronomy is ultimately a story about human persistence, about watching the sky not for a season or a year, but for centuries and millennia, about building knowledge slowly, observation by observation, generation after generation, without the dramatic breakthroughs that characterize modern science, but with a patient accumulation that eventually created deep understanding. It is a story about connection between heaven and earth, between the human and the divine, between the practical and the sacred, between past and future. The Egyptian astronomer priests saw themselves as maintaining cosmic order through their observations and rituals, participating in Ma'at through their careful attention to the sky. It is a story about transmission, about knowledge preserved in stone and papyrus, in oral tradition and architectural alignment, in systems of education that passed astronomical wisdom from teacher to student across countless generations, about the fragility of that transmission, how easily knowledge can be lost, yet also its resilience, how information encoded in stone can survive when everything else fades. It is a story about wonder, about human beings looking up at the night sky and seeing not just random lights, but pattern, meaning, beauty, mystery, about the impulse to understand that has driven astronomical inquiry from the earliest times to the present day. And it is, perhaps, a story that is not finished. The archaeological work continues, new discoveries emerge, our understanding deepens. The ancient Egyptians are speaking to us still, through their temples and texts, their instruments and alignments, their patient records of 5,000 years of watching the sky. What would those first Egyptian astronomers think if they could see where their observations led? They could not have imagined spacecraft visiting the planets they watched with naked eyes. They could not have conceived of telescopes that see to the edge of the universe, of mathematical models that predict celestial events with perfect precision, of the vast cosmic story modern astronomy has unveiled. Yet perhaps they would recognize something fundamental in modern astronomy: the same patient observation, the same careful record-keeping, the same belief that understanding the heavens matters deeply. The tools have changed beyond recognition, but the essential human activity remains: looking up, watching, wondering, attempting to comprehend. The flood star rises, though few now know to watch for it. The planets wander their ancient paths, their motions now explained but no less wondrous. The sun traces its yearly journey from southern horizon to northern and back again, marking the seasons as it has since, before human memory. And somewhere, a student of Egyptian astronomy sits in a library, studying an ancient text, attempting to decode the observations of a priest-astronomer who died 3,000 years ago. The connection is made across millennia, mediated by hieroglyphs and stone, but real nonetheless. The knowledge flows forward, adapted, interpreted, preserved. The conversation continues, between ancient and modern, between the Nile Valley and the world, between those who watched the sky millennia ago and those who watch it now. Different cultures, different times, different understanding, but the same human impulse, the same sense that the stars matter, that studying them is worth a lifetime, or many lifetimes, of effort. The sky goddess Nut still arches over the earth, though we no longer worship her. Ra still travels his daily path, though we call him the sun and understand his journey differently. The deacons still rise and set, though we no longer use them to mark the hours. The knowledge has changed, but the sky remains. And perhaps that is the deepest legacy of Egyptian astronomy, not the specific discoveries or methods, not the calendars or star tables, but the reminder that human beings have always looked up, always wondered, always sought to understand our place in the cosmos. The Egyptian astronomer priests, with their merkets and their patience, their temples and their traditions, were doing what we are still doing, what humans will presumably continue doing as long as our species endures, watching the sky, recording what we see, building knowledge slowly, carefully, passing it forward to those who come after, participating in the great human project of understanding, of connecting ourselves to something larger than our individual lives, of finding meaning in the movements of lights in the darkness. The night descends over Egypt. The stars emerge, point by point, filling the darkness with their ancient light. The Milky Way arcs overhead, that celestial river flowing through the heavens. In the east, a bright star rises, the same star that announced the flood to the first Egyptian astronomers, that marked the beginning of their year, that connected them to the cycles of cosmos and earth. The star rises, the night deepens, the universe turns in its vast cycles, indifferent yet somehow speaking to those who watch, those who wonder, those who dare to believe that understanding the heavens is worth dedicating one's life to pursuing. This was the Odyssey of Egyptian astronomy. This is its legacy, and this perhaps is its final gift, the reminder that we are part of an ancient tradition, that when we look up at the stars, we are continuing a conversation that began in the Nile Valley 5,000 years ago and continues still, unbroken despite the centuries, undimmed despite the distance. The stars abide, the knowledge flows forward, and the human story of reaching toward the heavens, of attempting to comprehend the cosmos, continues its ancient, endless journey. Welcome, then, to that journey. Welcome to the tradition. Welcome to the wonder. The Odyssey continues. The stars await.